Hello all, I am Dr. Karthika from Department of Biomedical Engineering, SNS College of Technology, Coimbatore, and today we are going to discuss about virtual reality physical modeling part 2. In part 1 we have discussed about traversal and collision detection. Okay. In stage 2, in haptics rendering pipeline, we have force. In force, we have force calculation, force smoothing, and force mapping. And after that, we have tactile, which is used for haptic texturing, and finally, we have output display. Okay, see here for haptic interface, see the example. Here we have haptic interface point at object polygon, and we have first a haptic interface point. After that we have point to haptic interface, and also we have to calculate the penetration distance for force calculation. See here in haptic interface, for any object we have to analyze and we have to calculate the penetration distance for force calculation and mapping. Okay. See here, force output for homogeneous elastic objects. Here F equal to Kd for 0 less than or equal to D less than or equal to D max. F max for D max less than D, where F max is that haptic interface maximum output force. See here, see the image of grasping a ball. Here we have F max, and we have soft object and hard object. Here we have a saturation point for each and every object, and we have D maximum point 1 and D maximum point 2, and finally we have penetration distance D. So to calculate the force, we have to know about the penetration distance D. Here we use D max 1 and D max 2, and also we use soft objects as well as hard objects, and we have saturation point. Okay. In this force calculation, elastic objects with harder interior means here the force is calculated by F equal to K1D for 0 less than or equal to D less than or equal to D discontinuity, and K1 multiplied with D discontinuity plus K2 multiplied with D minus D discontinuity for D discontinuity less than or equal to D, where D discontinuity is object stiffness change point. And here see here the D discontinuity and penetration distance D, which is mapped with the force F, actual measurements, and we have a computer model for virtual reality applications. Okay, see here the force calculation for virtual push button, and here F equal to K1D of 1 minus UM plus Fr multiplied with UM plus K2 multiplied with D minus N multiplied with UN, where UM and UN are the unit step functions at M and N. See here the virtual finger and virtual button. Here we have to calculate the force for virtual push button, so we need Fr, M, N, and virtual wall penetration distance D. Okay, and force calculation for plastic deformation, we have F initial, which is equal to K multiplied with D for 0 less than or equal to D less than or equal to M. F equal to 0 during relaxation point, and F subsequent, it is equal to K1D multiplied with UM for 0 less than or equal to D less than or equal to N. F equal to 0 during relaxation point, where UM is unit step function at point M. See here, see the graphs. Here we have feedback forces and compression and relaxation for deformation, and also we use compression and relaxation at maximum point deformation for various objects. This force calculation for plastic deformation. Okay, see here force calculation for virtual wall. Here F equal to K wall multiplied with del X plus BV for V less than 0. K wall multiplied with del X for V greater than or equal to 0, where B is the directional damper. And here see here virtual wall at V less than 0. And see the second one, virtual wall, and here the ball is moving into the wall. And the third one, v greater than or equal to 0 for virtual wall. And last one is moving away from the wall. See here the differences of v less than 0 and moving into the wall, v greater than or equal to 0 and moving away from the wall. Here it will generate energy due to sampling time. To avoid system instabilities, we add a damping term here, where B is a directional damper. Okay, in this haptics rendering pipeline, for force calculation is first one, second one is force smoothing. See here, for force shading, which is under force smoothing, here we have non-shaded contact forces, polygonal force and non-shaded contact forces. Second one, it indicates real cylinder contact forces, and the third one is contact forces after shading. And here the formula is F smoothed, it is equal to K object multiplied with D multiplied with N bar for 0 less than or equal to D less than or equal to D max. F max multiplied with N bar for D max less than D, where N bar is the direction of the contact force based on the vertex normal interpolation. Okay, I think we'll get a better understanding about force calculation, force mapping and force smoothing in virtual reality environment. And in next series we are going to discuss about virtual reality other types of modeling, like kinematics modeling, geometric modeling and behavioral modeling. Thank you.